Welcome back to another edition of HaugoMATH video. I'm super excited because in this episode I've actually stumbled upon an old treasure map from the 1500s from a Caribbean pirate named Supplementary Sam. Want to join me for an adventure? Let's set sail! Well, I thought this was going to be super easy, but it looks like that the treasure has actually been moved. So it'll be a little bit more work. But luckily I found a scroll of parchments written by Supplementary Sam himself. It looks like that's going to lead us on our way. We may have to do a little work with angles, but I'm sure we're going to end up finding this treasure. Let's do it.
Alas, the treasure was easily going to be found, so I, Supplementary Sam, moved it around. If you want some treasure, ignoring my map is what you'll do. As you traverse this island surrounded by blue, he needs to know about angles to pass my test. But this one is harder than all the rest. Find me treasure and he can take a bow, but if he doesn't know about angles, then turn back now.
Well, I guess I better dig deep and try and remember all I can about angles to give us our best chance to find this treasure. So an angle is basically made up of two lines called legs connecting at a point called the vertex. And we use a protractor as our measuring device to measure the angle measurement of an angle. So to measure an angle, one has to line up the vertex of the angle with the little place for the vertex on the protractor. And then you align one leg along the 0 line, and then you just count along the curved number line how many numbers or degrees it takes to make the opening. So in this instance, we need to bring down our protractor, line up the vertex, and make sure we get the 0 line aligned. Good to go, vertex on the mark, 0 on the leg. Now we count up along the number line and see how many degrees it takes. So here we're at 40, and then it looks like 1, 2, 3 more tick marks passed. It is a 43-degree angle. So why do we have two sets of number lines counting from 0 up to 180? Well, that just allows us to measure the angle if it was going the other way as well. So I just flipped the angle here. This is still a 43-degree angle. I'm aligning my vertex, getting the 0 set on the leg. And again, we count up, this time using the inside numbers, 10, 20, 30, 40, and 3 tick marks passed. Again, this is still a 43-degree angle, no matter how you measure it. Either way.
Sail to the Caribbean, and here ye go. Ask and find Vertex Island, not many will know. It is unmarked, for I made it myself from lots of sand piled on a coral shelf. Start at the peninsula that's southwestern the most. Be sure of no missteps, or else you'll be a ghost. My X is your vertex drawn in the sand. A leg of the angle is the 6th mountain in the band. Draw your acute angle north to the 50th degree, and now ye will be where ye needs to be.
Alright, let's get to work. Okay, so here's our first angle type, an acute angle. A very narrow opening between the legs here. Less than 90 degrees. Okay, so here is our vertex in the sand on the peninsula over here. This will be our leg matching up with the 6th mountain in the band. And we need to draw a 50-degree acute angle heading north. So to make a 50-degree angle, we first choose where our vertex is draw one leg, and then just count to the angle measurement that we need our angle to be. In this case, 50 degrees. So it looks like we're headed to Skull Cove. That's our next location.
To find all new riches, he has to go forth in a 90-degree direction up to the north. He now is the vertex one leg the last high top point. So draw a right angle north to find your next joint.
So our next angle is called a right angle. It's exactly 90 degrees. And oftentimes, a right angle is designated by this little square box. So Sam did say that we are now the vertex, right at Skull Cove, and the leg was going to be to the last high top point. So vertex on the mark, the leg on the 0 line, and count us up to 90 degrees. There is our 90-degree angle going north. So it looks like we need to make our way to Brown Beach. Let's do it.
And now from here on leg to the cove, you is just there, and draw an obtuse angle east if ye dare. Make it very carefully at 140 degrees, or head home now, I couldn't care less if that's what ye please.
Okay, so our next angle, the obtuse angle, is a very wide open angle from one leg to the other. Anything greater than 90 degrees is obtuse. So again, here we are now at Brown Beach. We are again the vertex. And where we just came from, Skull Cove, is the leg. So our vertex is on the mark, our leg is on the 0, and now 140 degrees. This obtuse angle is going to go way over here. So that looks good. 140 degree obtuse angle. All right, where to next now?
Almost there, just one more step. All the information along the way I hope you kept. The measures you made of the acute and obtuse angle, well, ye need them now, else get in a tangle. Find the sum of the complement and also the supplement. Are you confused? Did ye forget where ye went? With that sum, you will also have to combine the total number of vertical angles on the map that ye find.
Okay, so we got three things we're going to talk about. The first one being the complementary angles. So complementary angles are any angles that together form a right angle. 60 and 30 form 90. These are complementary angles. Connected angles that together make 90 degrees. So number 2 would be the supplementary angles. So a straight line actually is considered to be a straight angle or a 180 degree angle, because the whole angle would go all the way around the protractor, making it 180 degrees. Supplementary angles are any angles that together combine to make 180. And lastly, vertical angles are actually developed when you have two intersecting lines. You get two sets of congruent angles. The top and bottom are identical. The left and right also identical. So first, the complement to our acute angle of 50 degrees would have to be 40 degrees, because together that makes 90 degrees. And the supplement to our obtuse angle here would have to be 40 degrees. So Sam did say that we need to take the complement plus the supplement. I think he was trying to trick us there, because those are both 40. But also add that to the number of vertical angles that we see on the map. So by my accounts, the two X's, the crossbones, the crossing swords, and the compass, that makes 5 vertical angles. Find that sum, and that's 85.
So now look at some what do you do? That's the number of paces to walk east towards the blue. Stop when you arrive and dig in the sand. Ye has proven to be worthy and may take the treasure from me land.
Alright, 85 paces due east from the location of Palm Tree Peninsula. I'm here. Let's start digging. Ooh. I think I feel something here. I think we found it. Woo-wee! We're rich! I knew all that knowledge about angles would pay off someday. Woo!
Congratulations, treasure hunter. You have found the prize, but sailing home through the Bermuda Triangle, you'll need to use your eyes. Many have become lost and have never returned, so one last lesson involving triangles to test what you've learned. The more you know of triangles, the better your shot of returning home with the treasure ye got.
There it is, the Bermuda Triangle. Strange natural phenomenon here. A lot of ships have gone down, planes lost at sea. This is definitely something that we do not want to mess with. Let's learn about triangles, and maybe this triangle will be kind to us then. So Supplementary Sam did say that as long as we learn one fact about triangles, that the Bermuda Triangle would be kind to us and let us pass. Well, triangles are made of 3 angles. No matter if that's a right triangle or some other kind of triangle, 3 angles. And if we start pulling these angles down, there is an interesting relationship with the angles of each individual triangle. So let's organize these 3 angles and these 3 angles in a different way so we can see that relationship. So when we take the first triangle's 3 angles and put them together, what have we formed? We have just formed a straight line. Basically, supplementary angles here, 180 degrees in all. And the same holds true for the second triangle's angles. Let's push those together, and what have we just formed? The same thing. 180 degrees of angle. Therefore, we can conclude that any triangle, no matter the size or the shape, will always have 180 degrees of total angles from all 3 angle measurements. And that's the relationship with all triangles. Alright, let's sail home to safety and spend all of our riches. But the real riches here is all the knowledge that we've gained about angles today. Have a great night, and I'll see you on the next treasure hunt. Good night!